Hi everyone. In this video, we're going to talk about what an acid and a base is, and we'll talk about how to name them. So the word acid comes from the Latin word acidus, which means sour. So most fruits that you're familiar with that have a sour taste, like citrus, lemons, and limes, they're sour because they contain a lot of natural acids. So how do we define an acid? Well, the first scientist who ever described acids was named Arrhenius. So this is the Arrhenius definition. An acid is anything that produces hydrogen ions, H plus, when they're dissolved in water. So here's an example of an acid. HCl, when you mix it with water, dissociates and gives H plus and chloride. And so because it gives off H plus, we define it as an acid. And so since the acid gives off ions, it's technically also an electrolyte. So acids give off hydrogen, they have a sour taste, and they are corrosive to certain metals. So let's talk about how to name these. So acids are named based on their anion. So they're always going to have H plus as the cation, and then they're going to have some various negatively charged anion. Now, there are three different endings or suffixes for anions. They can end in IDE, ATE, or ITE. And you've seen this before with naming. And so the suffix determines how we name the acid. And so here's an example. If the anion is chloride, the acid would be HCl, and we would name it hydrochloric acid. If the anion is nitrate, it would be HNO3 as the acid. So we would call it nitric acid. Or if the anion is nitrite, the acid would be HNO2, and we would name it nitrous acid. So let's take a look at these three different situations in detail. So binary acids are those that have only two elements, hydrogen and one other anion element. And they typically end in IDE. So if the anion ends in IDE, we add the prefix hydro, and then we change the ending to ic acid. So chloride becomes hydrochloric acid. Another example of this, let's say we have Br minus. This would be bromide. And so the corresponding acid, HBr, we would name by using the prefix hydro. And then we would take the brom and add ic acid. So bromide versus hydrobromic acid. Now, the next type of acid is one that has a polyatomic ion. And so polyatomic ions can end in either ATE or ITE. If it ends in ate, we change the ending to ic acid. So sulfate would be sulfuric acid. The polyatomic ion ends in ite, we change it to OUS acid. So sulfite would be sulfurous acid. So here's a chart showing the names of most common acids. So hydrochloric, hydrobromic, hydroiodic, and nitric, nitrous, sulfuric, sulfurous. And so you can see here, once again, if it ends in IDE for the anion, we add hydro and then change it to ic acid. If the polyatomic ion ends in ATE, we just change it to ic acid. And if it ends in ITE, we change it to OUS acid. Okay. Now, acids can be monoprotic, diprotic, or triprotic. And this refers to how many hydrogen ions the acid can give off. So a monoprotic acid gives off one hydrogen atom. Now, hydrogen ions are often referred to as protons. And this is because hydrogen only has one proton and one electron. And so if it's positively charged, meaning it lost the electron, it's literally just a proton. So hydrogen ions are the same thing as just a proton. So monoprotic acids give off 1 proton. A diprotic acid gives off 2 protons, or 2 hydrogen ions. And a triprotic acid gives off 3 hydrogens. All right, let's do a study check on naming real quick. Name each of the following acids. So in order to name the acid, we have to look at what anion it's attached to. So here, this is attached to a Br minus, which is named bromide. So the acid name would be hydrobromic acid. Right? So if it's IDE, you add hydro and then change it to ic acid. The next one is a polyatomic, and this anion, CO3 2 minus, is named carbonate. And so the polyatomic ion ends in ATE. So when we name the acid, this would be carbonic acid. We change it to ic acid. And this last one here, the anion is SO3 2 minus, and this is named sulfite. And so the acid would be sulfurous acid. So the ITE turns into OUS acid. Now, let's talk about bases. So Arrhenius defined a base as anything that produces hydroxide ions, OH minus. Now, bases taste bitter or chalky. They feel soapy in your hands. And they're technically also electrolytes because they produce ions when dissolved in water. So an example of a base would be sodium hydroxide. When you mix it in water, it dissociates to give sodium and hydroxide. So because it gives off OH minus, it's a base. And so for naming bases, you basically just name the metal followed by hydroxide. So sodium hydroxide, potassium hydroxide, barium hydroxide, aluminum hydroxide. Let's do a quick study check here. Match the formulas with the names. So HNO2. Well, it has a hydrogen out front, so it's definitely an acid. And NO2 is nitrite, so this should be nitrous acid, D. And then this is calcium hydroxide. So that was easy. And that's a base. H2SO4. It has hydrogen out front, so it's an acid. SO4 is sulfate. So this will be sulfuric acid. This one is an acid because it has hydrogen out front. PO4 is phosphate. So this should be phosphoric acid. Okay. And last but not least, sodium hydroxide, another common base. Let's do one more study check. Identify each as a characteristic of an acid or a base. So sour taste. Well, anything that's acidic is a sour taste. So that's going to be an acid. Produces hydroxide ions in aqueous solution. Well, that's going to be a base, right? Bases give OH minus. Has a chalky taste. Well, that's going to be a base. Is an electrolyte. So both acids and bases ionize when dissolved in water. So both acids and bases are electrolytes. And what produces hydrogen ions in aqueous solution? That's going to be an acid. All right, and then that's it for this video. Thanks for watching, and I'll see you in the next one.